There is a $3,000 refrigerator sitting in thousands of American kitchens right now. It has a touchscreen the size of a small television bolted to the front door. It plays music. It has a camera inside so you can check your groceries from the store. It will be landfill in 5 years. Not because the cooling box fails. The cooling box is $300 of insulation, a compressor, and copper tubing. That part works fine. What kills it is the consumer tablet the manufacturer glued to the door, running on an operating system with a 4-year support life cycle. When Samsung decides that software is obsolete, the apps crash. The screen throws errors. The touchscreen dies. Now you have a perfectly functional refrigerator that looks broken, that your family hates, and that the technician will tell you costs more to fix than replace. That is not a malfunction. That is the business model. This is the forensic audit of the modern refrigerator. We are going through the engineering decisions, one by one, that transform the most reliable appliance ever manufactured into a replacement cycle disguised as a kitchen upgrade. Start with the physics. Your grandmother's refrigerator had the freezer on top for a reason. Cold air is denser than warm air. Cold air sinks. In a top freezer configuration, the cold generated above falls naturally into the fresh food section below. Gravity does the work. The compressor runs lean, slow, and cool. The French door refrigerator with its freezer drawer at the bottom does the exact opposite. To maintain temperature, manufacturers have to force cold air upward into the fresh food compartment. That requires a second evaporator coil for the upper section, an additional electronic fan assembly, and a control board sophisticated enough to manage 2 separate cooling zones simultaneously. All of that electronic infrastructure runs in a cold, humid environment every hour of every day. Every component you add is a new failure point. The French door refrigerator is an appliance built to fight thermodynamics until it loses. Now, the feature that appliance repair technicians call their job security, the door-mounted ice maker. The ice maker mechanism sits inside the freezer door, which is the warmest part of the cabinet because it gets opened roughly 20 times a day. Warm kitchen air rushes in every single cycle. The ice maker works constantly just to stay frozen. Then there are the water lines. To supply an ice maker inside the door, manufacturers route pressurized plastic water lines through the door hinge. That hinge gets yanked open and slammed shut thousands of times a year. The plastic lines pinch. They develop fractures. Ice forms, melts, refreezes, and jams the motor. The motor seizes and draws excess current back to the display board. Now your repair estimate is $400 and the technician is booked 2 weeks out. Buy a plastic ice tray. $2. It will outlive your mortgage. Here is something the industry does not advertise. The refrigerant in your modern compressor is essentially the same gas that fuels a camping lantern. In response to EPA energy efficiency mandates, manufacturers switched to R600A, which is isobutane. That gas is highly flammable and efficient at low volumes. To hit energy targets, engineers designed smaller compressors running at high RPM. The result is a compressor operating near maximum capacity every hour of every day, wearing itself out in 4 to 5 years. The older compressors and machines from the 1980s and 1990s were large, cast iron, low-speed motors that rarely exceeded 60% of their operational capacity. They ran cool, they ran slow, they ran for 30 years. The new compressors are optimized for an EPA rating on a spec sheet, not for the lifespan of the cabinet they are installed in. Which brings us to the loophole. Estate sales, Craigslist, Marketplace, you will find them. Beige, almond, sometimes white. Kenmore or Whirlpool refrigerators from 1985 to 2005. Sellers want them gone because the color is wrong for the kitchen. Buy one anyway. Those machines use the heavy cast iron compressors the industry abandoned when energy ratings became a marketing tool. Yes, an older unit uses roughly $20 more in electricity per year. Over 10 years, that is $200. One modern compressor replacement costs $400 to $600. One control board failure costs $300. The old beige fridge is not ugly. It is a hedge against the replacement cycle the industry engineered for your wallet. If you must buy new today, here is exactly what you want. Top freezer configuration. A Mana or Frigidaire. No water dispenser, no ice maker. When you open the refrigerator door, look up at the interior ceiling. You are looking for a mechanical damper, a physical plastic dial on a metal spring that controls airflow between the freezer and the fresh food section. No circuit board, no firmware, no software support end-of-life date. Just plastic on a spring, working the same way in 30 years as it does today. If you see a digital keypad or touchscreen inside the refrigerator, close the door and walk away. For anyone with a serious budget and a permanent home, look at what the restaurant industry actually buys. Commercial brands like True Residential or Sub-Zero. The critical engineering difference is compressor placement. Commercial refrigerators mount the compressor on top. Heat rises. A top-mounted compressor dissipates heat upward, away from the machine, running significantly cooler than consumer units that stuff the compressor into a cramped rear cavity where it chokes on dust and peat hair. Beyond that, commercial refrigerators are designed to be serviced. Standardized parts are available from multiple suppliers. A technician can order a True Residential compressor from a parts house and have it installed in an afternoon. A Samsung Family Hub requires proprietary components and a manufacturer-authorized service visit with labor rates that make replacement the sensible financial choice. That is not a coincidence. Here is the summary. The modern refrigerator is a depreciating consumer electronics device marketed as a durable good. The touchscreen, the bottom freezer, the indoor ice maker, the high-speed compressor. Each feature reduces the serviceable lifespan of the machine in exchange for a specification that photographs well in an ad. If you need to buy new, buy the top freezer, a Mana, with the mechanical damper. If you have the budget and the intention to stay, buy the True Residential or Sub-Zero and have it serviced when it needs it. And if a salesman tries to sell you a refrigerator with a built-in calendar and a touchscreen display, ask him one question. What is the software support end-of-life date? Watch what happens next. The next video is on screen now. Subscribe so you don't miss the next audit.